Welcome everyone to the class. Today we're going to be covering Chapter 1, essentially how websites work. This will be the only lecture that is pure PowerPoint. The rest of the lectures in the class will be half PowerPoint and half of a coding session. But for this one, since we're just covering information, it's going to be just pure PowerPoint. First things first, I want to go over a few basic concepts, mainly browsers. If you've ever been on a computer in the past 2 decades, chances are you've used an internet browser to do something. Either go on Facebook, go on Google, check something out on Amazon. Basically, you've done something using a browser, whether on your computer, your desktop, or your mobile device. Just a bit of a history. The first browser that made big news was Internet Explorer back in 1995. That came with pretty much every single Windows desktop, and it was pretty much the primary browser everyone used up to about 2018 when it was finally retired. People still use Internet Explorer, but it's starting to lose popularity over Edge. Edge is the more recommended browser for Windows users. If you don't want to use Edge or Internet Explorer and have a little more security, then I'd recommend Firefox. It was Netscape back in 1994 and then eventually became Firefox around the turn of the century. And a close contender behind that is Chrome from Google. Safari is included with pretty much every Mac device out there, and it's good but not as flexible as Firefox and Chrome. Chrome is usually the browser of choice for developers, along with the fact that you can add things such as extensions and have your usernames and passwords saved. Firefox has made a lot of changes in the past year, and they are certainly catching up to Chrome's popularity. Alright, so basically, how do websites work? We have a general browser. In this case, I'm going to use Chrome, just as an example. Part of the website internet network system is, of course, we have the internet. I'm not going to go into fine details behind that because that can be a whole entire class on its own. But then at the end, we have our web server, and the web server itself is going to do a lot of things. But first, what needs to happen? We need to make a request from our computer or device to the internet to find a website. The internet will be processing things such as the fully qualified domain name, or FQDN, running things through a domain name service or server, DNS, running things through the internet protocols or IP addresses, processing firewalls, making sure that ports are open, and other services behind the scenes. Beyond that, it takes the request and sends it to the proper web server to be processed. That web server goes through things such as finding the necessary files, processing the necessary files needed, referencing the databases, going into APIs, pulling that information, parsing the data, and analyzing security. Once it has everything it needs to go back, it sends that information back through the internet, back to your device, and loads up the web page. In this case, it is Google. This is an extremely simplified version of how things work on the internet, but hopefully you have a better understanding about how things work between point A, point B, point C, and back to point A. When you're talking about website files, basically websites are just made up of multiple files of different extensions and different types. In this case, in the picture, we have an HTML file, a JavaScript file, another HTML file, a PNG or an image, and a CSS or a styling file. Websites all over the world consist of just a cluster of files that make up the necessary information needed between the server and the client and everything else to make that website create the content. For most websites, they are run through a web server before being served back to the client. In this case, it is you, me, or anybody else trying to browse the site. When we're talking about where to store these files, the majority of the time it's going to be in something called the root folder. And this is where the first information for a website should be found when loading the website. Usually contains the index page. I'll go to that in just a minute. If you're on a local machine, usually this is the directory you are using for that website. Inside the root folder, you can have subfolders, and inside those subfolders, you can have pages and pictures and audio files and anything else that you want inside that one web page area. When you're going to be organizing your files, you want to make sure that the organization for your files is a little more streamlined than just dumping a bunch of stuff into one local folder. In this case on the left, we have everything located under one specific folder and nothing is organized. which may seem a little straightforward to go ahead and just add all those files together, but when you're dealing with, say, 10,000 files, it can get very confusing very fast. So what's better? Well, instead of just having everything under one folder, have everything under its own relative folder, such as About, or Assets, or Audio, or Contact, or CSS, etc. So that way it's easy to find, easy to navigate, and you're not going to get lost trying to find the file you need to find. Additionally, if you notice, on the left we have About Page, Animation, Contact Page, etc. On the right we have About Folder, we have a Contact folder, and inside those folders we have index.html. Again, this is what's going to be loaded as soon as that folder is found. Otherwise, you're just loading the file itself. When you're naming files, you always want to make sure the file name is something short and relevant. If you're naming files such on a numerical system, such as file 1, file 2, file 3, then you're going to get lost trying to find the exact file you need and the exact information in that file because everything is named so similar. Additionally, if you have a page file or a page name that has a super long file name, such as page after loading customers information.html, that's going to get more complicated once you're starting to load more pages. Chances are the more letters you have, the easier it's going to be to mistype something or accidentally forget to save it as the appropriate name, and therefore you can't find the file because, well, you mistyped the name or the name is incorrect. I would recommend something simple and easy such as index.html, we'll get to that in just a minute, about, gallery-page, thank-you, etc. Something easy, something not too complex. If you're on a Windows or a Mac machine, or if your website is on a Windows or a Mac machine, then uppercase names are not an issue. Uppercase file and lowercase file are the same exact file. However, if you are on a Linux machine, or if your website's on a Linux machine, then the uppercase is treated differently. Uppercase file and lowercase file are two different files, which means that instead of just finding the one location, it'll find two, or if you're trying to locate the uppercase one and only the lowercase exists, it's not going to find it. So I would go ahead and get into the good practice of making sure that your uppercase and lowercase files are treated differently. Otherwise, it's going to be really hard to break a bad habit. Now, as far as industry practices, the first main page that should be loaded, whether it's in the root folder or it's in a subfolder or it's somewhere else, should be named index. Whether it's index.html, index.php, index.asp, whatever the file extension is, it should be named index. This is the first page that's going to be found and loaded in the web server or the website that's being loaded. In some cases, some web servers accept defaults, like default.html, but do not use, and I cannot express this enough, do not use home.html or main.html. Always use index. It's a good practice to get into and is something that your other developers will thank you for. If your web server is not set up to accept index or defaults, chances are it won't load home or main. So you want to make sure that you have index listed, and if your web server isn't learning that, then you may need to reconfigure the web server to load it. You also want to get into the practice of using lowercase letters. This way you won't get confused as to what capitalization was used in the file name. If you just use all lowercase letters, then you'll be perfectly fine. You know exactly what the standard file naming practice is for you. Next, don't use spaces in file names. When you're loading files on a web server, sometimes spaces are seen as a special character, or in this case, %20. Which can confuse the server and possibly you as well. When you're trying to load something that has a space in the file name, you don't know whether or not to put the %20 in there or not. And if you don't, it can get very confusing trying to find out why your specific file isn't loading. This goes for file names, folder names, pretty much anything on your computer or the web server. Lastly, if you need to use hyphens or underscores, use hyphens over the underscores. That way you're not having to worry about different file names being loaded in case you have an underscore versus a hyphen. This way you know exactly what you're going to be using. Now, with web servers, there are plenty of web servers available. You can even configure your own on your own computer with Apache, XAMPP, MAMP, or another service that, if you have a bit of a tech skill, you can certainly set it up yourself. Otherwise, you're going to be looking at a third-party service to host your website. Basic services cost about $10 a month, and they can have higher prices for advanced features. But don't be swindled by the features if you don't need them. If some services out there offering for free email addresses or a free domain or unlimited disk space, do your research before you sign a contract with them or even just sign up. When you're researching web servers, you want to make sure that you're going to have the correct information before you make a decision to host your website or even a client's website with this company. For example, with domain names, do you own that domain name? Chances are, if you're signing up with a free service, you do not. And if you're going to be taking that domain to somebody else, you may not have the right to do so. Additionally, you may only have the capability to have a subdomain, in which case it's yourdomain.website.com, which may work for testing purposes, but if you're trying to establish a professional image, not exactly the best thing to have. On top of that, you want to make sure that anything you have for renewals after a year, 2 years, 3 years, however long the domain is you have, you want to make sure that the renewal process is quite easy, if not quite cheap. Disk space. Do you know how much space your site will take up? If you don't, you may not want to sign up with cheap web hosting services. They may only give you 512 megabytes, but chances are, do you really know how much that is? Are they talking about RAM or are they talking about hard drive space? If they just say 512 megabytes, you don't know what that is. And chances are, if you don't know what that is, then you may need to do a little more research. Specifically, do you know what the difference is between 10 megabytes and 10 gigabytes? One is 1024 times 10, so in this case 10,000 times more than the other. Take a guess at which one is which. And if your site only takes up 10 megabytes, then do you need to really pay for 10 gigabytes? Or let's take the exact opposite. If your website takes up 10 gigabytes, which I surely hope it does not, and the web service is only giving you 10 megabytes, then you only have less than 1% of the space necessary to load your site. Bandwidth. If you go over the amount of speed or amount of data transference between your clients and your web server, is your web service going to throttle you? Basically, if you don't know what that means, it means that after you reach a certain point of data, for example, with your cell phones, the web service is going to start slowing your service down. And in this day and age, well, clients don't want to wait a long time for your website to load, and chances are if it's more than 3 seconds, they'll go away. Support. What kind of support does a web service provide? Do they provide email support, phone support, forum-only support, which means you can't contact anyone at the company? It's up to you to browse through the forums and see exactly how you can solve your own problem. And lastly, what is the cost for support? If the service does not provide a cost for support, they may charge you $1 per minute or $100 per minute or $100 per task. It just depends. So again, do your research. Backups. If something happens to your website, you upload a bad piece of code and therefore it crashes your whole server, does the web service provide backups? Are they free? How often do they back up? Most web services back up on a nightly basis, which means that anything you upload and destroy, you should be able to go back a little less than 24 hours to pull the last backup from anything they have. But some web services don't like this, and therefore they'll back up only once a week, once a month, once a quarter, once a year. Which means that if you have something that you messed up and you need to pull from the latest backup, well, if that backup is from July of 2016, it's not going to do you much good. Additionally, some services tell you that they'll pull the backup for you for a cost, and that cost can be extraordinarily high depending on the web service and if you did your research. Towards the bottom, if you don't know what POP or IMAP is, that is basically your email. Sometimes some web services will give you the capability to have an email address associated with a domain, which is great. However, sometimes they only allow you to access it via their own website. If you want to use Gmail or you want to use Outlook or you want to use something else to pull your email from that server onto your own system, they may disable POP and IMAP access, which means that you have to use their service to do it. On top of that, how much space do you have for mail? What security is provided for your mail? And last but not least, are ads provided? You would like a web service that manages your email without ads, but sometimes you just can't get around it. It depends on what you want to do. And last but not least, money back guarantees. Some of them will say that you have a 15-day or a 30-day or a 6-month money back guarantee. But is that as easy as no questions asked, or do you have to jump through certain hoops to get that money back? Do you have to have certain credentials? Do you have to have certain qualifications? Do you have to have something on your site that specifies what it is before you get your money back? A lot of web services can actually catch a lot of people with this because people want to pay a cheap price for a web service, but then they don't read the fine print, and before you know it, they're paying 10 years for this web service that they don't want to use in the first place. As far as domain names, again, if you are to get a domain name, I recommend going through a domain name registrar, not just getting a free domain from a web service. With this, you're going to be coming across a lot of different systems and a lot of different technical details when it comes to domain names. First, the TLD, or top level domain. Most common that everyone knows are the .com, .net, .org, and that's pretty much for anything nowadays, especially if you're going to be dealing with anything in commercial, anything on a network, or anything in an organization. Some countries can also take that and add their own country code, such as .co.jp or .co.uk. That way they have their own country-specific version. Special cases include .edu, .mil, or .gov, which means that you have to be a specialized service in order to get this TLD. Not anyone can just go out and register a .edu. You have to have certain credentials to qualify for these TLDs. And in the past 5 to 10 years, a lot of trendy TLDs have come up, such as .ninja, .club, .jobs, .rocks, and .io. If you recall from before setting up brackets, the domain we went to was brackets.io. Again, that is a trendy tech TLD. When you're shopping for domain names, you want to make sure that your domain name registrar is not going to upsell you on something. If, for example, the domain you're looking for is not available, such as myawesomesite.com, they may say, hey, instead of looking for .com, which is not available, how about .jobs or .house or .club? They may want to upsell you on it because they're trying to run a special on that TLD for, say, $8 or $10 a year, in which case once the renewal comes up, it's all of a sudden $150. Well, that's a bit of a shock, and hopefully the domain name registrar you're going to be using tells you that up front. So, if you're looking for upsells, be wary about what you're looking at. Last but not least, privacy. If you decide to go with a domain name registrar and you want to protect your information, which I highly recommend you do, you can pay a little extra for domain name privacy. What this means is that it's actually going to obfuscate your information from public records. On the left right here in the red box, you see a lot of personal information such as phone number, email address, street, city, and even your zip code. Well, if you pay a little extra, such as $3 to $4 per domain, you can get privacy protection such as the blue box on the right. What this means is that anyone who can find you, whether you buy a domain today, tomorrow, or 6 months from now, they can find you using the public information with domain registrars. If you have the privacy set up, that means that anyone that tries to find you, such as looking up recently purchased domains, they won't be able to contact you or mail you or email you or anything offering you services, because anyone who purchases a domain Some kind of company is going to contact them saying, do you want web services? And it's not exactly the best thing to do or deal with 40 times a day, especially if you can't understand them. All right, domain name servers. What they do is they translate fully qualified domain names to Internet Protocol addresses. For example, example.com. You have no idea where that lives in the world or what server it lives on, but a domain name system or a domain name service can translate that for you to 28.39.231.9, which for you is a lot easier to memorize example.com than it is that bunch of numbers. DNS services can provide an extra layer of protection and security for any clients that are trying to browse your website, and it also keeps a lot of records of how and where to process the data. Sounds confusing? Don't worry about it. With the first example, we have all these services going through a name server, and the name server says, hey, all this information that you're looking for is on the same server, so here it is. If we look at example 2, the name server says that, hey, you want the website? Go to this server. You want email? Go to this server. You want subdomains? Go to this server, etc. And the name server sets that up. You as the client don't have to worry about that, but the name server knows exactly where to go for what service is being requested. I highly recommend taking a look at Cloudflare, which is a great domain name system for you. You can take a look at that first link right there, or just go to cloudflare.com/DNS and it'll explain more about how DNS systems work. It's just a little extra reading in case you want to do it. Not required, but I would recommend it. Alright, languages of the web. First thing is, you want to make sure you understand what client-side and server-side languages are. Client-side languages are languages that work specifically on the client or your computer. And by your computer, I mean the one that you're using to browse the web, not develop on. Languages include HTML, CSS, and JavaScript. The majority of these languages create user-viewed content and generate requests to be sent to a server. You can have a web server that is providing these pages or these languages, but in most cases, you don't need one. For what we're doing, HTML, CSS, and JavaScript, you do not need a web server set up, like I said before. With the server-side languages, such as PHP, SQL, ASP, or Node.js, this actually takes the data that's being sent from the client side and processes it or manipulates the data, creates a structure behind it, and processes everything behind the scenes to generate something to send back to the client. So everything that you request for Google.com, the server-side language will generate all that information for you and send it back to your laptop or computer. It does require a web server to run. In this case, I would just list Apache, IIS, Node, or etc. In this case, everything that you're doing is going to be processed through the computer and built before being sent back. When you're developing your files, you want to make sure you know the separation of concerns. This may sound a little scary, but let me explain. What you want to do is separate your code into different code-specific files, such as HTML, CSS, and JavaScript or JS, especially for client-side languages. You don't want to use CSS in a JavaScript file. You don't really want to use HTML in JavaScript. You don't want to use JavaScript in an HTML file. Because if you're trying to make sure that all your code is clean and easy to understand and much less easy to organize, you want to make sure that everything is separated. Otherwise, you're having to go through and dig through files to find a specific piece of JavaScript or HTML or CSS in this case that may not be where it needs to be or should be before you need to load it. Lastly, you want to make sure that when you're developing your code and your pages, you keep progressive enhancement in mind. What this means is that regardless of who is viewing your website, you want to make sure they can load it without any special assistance. For example, this website right here. This website has the CSS and everything else stripped away from it. Does that mean that it's still able to be used? Yes. It's not as pretty or not as user-friendly as, say, one designed with CSS and JavaScript, but a person can still navigate the links on the page and go to the pages they want. Once you actually enable the CSS and JavaScript, you have something nice that looks a little more user-friendly than just text on a page. Last but not least, you want to make sure you're working with developer-friendly code. Chances are, once you get started with coding, you're going to put everything on the left-hand side, which is good, but it's a little hard to read once you're going through those thousands and thousands of lines to figure out exactly where a problem is, or much less, update some information. So what you want to do is actually indent your code and make sure that everything is properly aligned and everything is properly organized. That way it's easier for you to read, easier for you to debug, and if you're passing it off to anyone else, they can take care of it themselves and not have to go through you. So, for the end of chapter activity, what I want you to do is open a Word document or any word processor of your choosing and go through these 10 questions. All of them are required except number 6. I will consider number 6 extra credits, so you don't have to actually go out and find these web services and call them up. So, what is an IP address? What does a typical IP address look like? What is a fully qualified domain name? What does DNS stand for? What is the purpose of a DNS server? Number 6, etc. What are the programming languages for 3 concerns of web development? How can you accomplish separation of concerns? Explain the concept of progressive enhancement, and what does it mean for your code to be developer friendly, and why is it important? So, if you would, go ahead and put these into a Word document. They should be in the back of chapter 1 in your book, and send that to me by the end of Sunday night. That is, again, the time when everything should be due. If you have any questions, please email me at kyleperkins@abtech.edu or on Twitter at KyleMPerkins, and I'll try my best to help you out and hopefully find an answer to your question. Until then, let's move on to chapter 2.